All right, welcome to the Explainer. Today, we're diving straight into a brand new, highly anticipated research paper from NVIDIA. It's all about their groundbreaking Nemotron 3 supermodel. Now, if you've been following the massive leaps in AI recently, you know the race isn't just about making these models smarter anymore. It's really about making them vastly more efficient. And NVIDIA's latest paper, which is titled Nemotron 3 Super, Open, Efficient Mixture-of-Experts Hybrid Mamba-Transformer Model for Agentic Reasoning, is a huge leap forward in exactly that space. We're going to unpack exactly how they pulled this off, relying entirely on the data and the architecture they presented.
So here's our roadmap to understanding how NVIDIA's solved some of modern AI's biggest compute bottlenecks. We've got 1. Meet Nemotron 3 Super. 2. Inside the hybrid architecture. 3. Training the giant. 4. Benchmarks and inference speed. And 5. Open sourcing AI's future. Let's get right into it.
How do you actually make a massive AI model faster? You know, that's literally the core problem AI developers are wrestling with today. Because as models get better at complex agentic reasoning, meaning they can plan, execute multi-step tasks, and really act like autonomous agents, they inherently become slower and incredibly expensive to run. The computational bottleneck during inference, when the model is actually generating its responses, is honestly the biggest hurdle preventing advanced AI from being deployed everywhere. You constantly have to balance that heavy, complex reasoning capability with the desperate need for blazing fast inference speeds.
To really grasp the scale of NVIDIA's solution here, we first have to look at this massive parameter count, 120 billion. Parameters, as you probably know, are essentially the artificial synapses of an AI model. They hold all the logic and knowledge it's learned. Traditionally, a 120 billion parameter model would require a massive supercomputer just to spit out a simple sentence, which makes it painfully slow for any real-time application. But, spoiler alert, NVIDIA found a brilliant way to sidestep all that massive weight. Section 1. Meet Nemotron 3 Super. 3 breakthrough firsts. So these 3 highly technical breakthroughs specifically target inference acceleration. According to the paper, Nemotron 3 Super is actually the very first in its family to hit these milestones. First off, it's pre-trained in NVFB4. That's an ultra-efficient data format that shrinks the model's memory footprint down so it can process information way faster. Second, it leverages LatentMoE, a specialized mixture-of-experts architecture. And third, it includes MTP layers to natively perform speculative decoding. Now, I know that's a lot of jargon, so let's break down how this actually works under the hood. Moving right along to Section 2, inside the hybrid architecture, Mamba meets Transformer. Okay, so the secret sauce really begins by blending the traditional transformer architecture with Mamba, which, if you remember, is built specifically for efficient, linear data processing over really long sequences. And then we bring in MoE, or Mixture of Experts. Think of MoE kind of like a massive global corporation. If you have a highly specific legal question, right, you don't page the entire company to answer it. You just ping the specific specialist in the legal department. Mixture of Experts does the exact same thing for neural networks. Instead of forcing the entire 120 billion parameter model to crunch every single word of your prompt, it routes the task only to the specific expert subnetworks that are actually trained to handle it. And this is where it gets crazy. Despite being a 120 billion parameter giant overall, Nemotron 3 Super only uses 12 billion active parameters at any one time during inference. By dropping the active workload to just 10% of its total brain power for any given token, the computational overhead absolutely plummets and the speed skyrockets. It is literally the perfect balance. You get this massive, diverse knowledge base, but you're only carrying the specific tools you need for the job at hand. But here's the thing. NVIDIA didn't just use standard MoE. They introduced LatentMoE and combined it with those MTP layers we mentioned a minute ago. The researchers explicitly note in the paper that LatentMoE optimizes for both accuracy per flop, which is basically a measure of raw computing power, and accuracy per parameter. By utilizing these elements for native speculative decoding, Nemotron is essentially guessing and verifying its own future outputs super rapidly in parallel. It acts as its own speed booster, predicting the next several words all at once and verifying them instead of painstakingly calculating them one by one. All right, Section 3, Training the Giant, from tokens to agentic reasoning. The training lifecycle detailed in NVIDIA's paper starts with an absolute mind-boggling diet of 25 trillion tokens. And a token is basically just a piece of a word. So 25 trillion tokens is roughly equivalent to absorbing the text of millions upon millions of books, websites, and code repositories. It's wild. But raw knowledge isn't quite enough for an AI agent. That is why they move to step 2, supervised fine-tuning, or SFT, where the model learns how to properly format its answers and follow instructions. And finally, in step 3, reinforcement learning aligns the model's behavior. This is what teaches it that complex, multi-step agentic reasoning so it can actually solve difficult, layered problems rather than just, mimicking human speech. All that rigorous training results in a model with a truly staggering capability, a 1 million token context length. Now, context length is essentially the model's short-term memory during a conversation. Having a 1 million token context length means Nemotron 3 Super can process entire libraries of books, exhaustive legal case files, or massive, sprawling software code bases, all in a single unified prompt. It can hold all of that context in its mind at once and reason across the whole thing without forgetting what it read at the very beginning. Next up, Section 4, benchmarks and inference speed, breaking the bottleneck. So, when benchmarked against other massive models in the 120 billion parameter weight class, Nemotron 3 Super completely blasts past them in speed, all while maintaining comparable accuracy and reasoning scores. I mean, it hits 2.2 times higher inference throughput than GPT-OSS-120B, and it achieves a staggering 7.5 times higher throughput than Qwen3.5-122B. To put that into perspective for a developer or a business, a 7.5x increase in speed translates directly to massive savings in server costs and a vastly superior lag-free user experience. It's a real game changer. And finally, Section 5, open sourcing AI's future, available to the public. Now, despite the enormous resources required to build this thing, we're talking about those 25 trillion tokens and hundreds of researchers at NVIDIA, this breakthrough is not locked behind some expensive, closed corporate API. NVIDIA has generously open-sourced the entire ecosystem. Right now, over on HuggingFace, developers can access the actual datasets used, the base pre-trained checkpoints, the post-trained checkpoints that have undergone all that complex fine-tuning, and even the quantized checkpoints that are optimized for lower-end hardware. They're empowering anyone in the world, from university researchers to startup founders, to just download, analyze, and build upon this cutting-edge hybrid Mamba-Transformer architecture. It's an absolutely massive win for the open-source community. The tools for the next generation of hyper-efficient, agentic reasoning are now freely in your hands. This completely changes the math on what's possible for independent developers to run and deploy on their own, which leaves us with one big question to close out this explainer. With the blazing speed of a lightweight model and the sheer brain power of a 120 billion parameter giant, what are you going to build? Thanks so much for joining me on this deep dive into NVIDIA's Nemotron 3 Super. Keep exploring, keep building, and I'll catch you in the next explainer.